Hello students, previously from 4 topic 2 lesson 14 we were dealing with the relationship between heat of solution, lattice energy and hydration energy. So in lesson 15 today we want to do examples on the relationship between heat of solution, lattice energy and also hydration energy. So example 1, we are told to study the information below to calculate the heat of solution of sodium chloride, then draw an energy level diagram for the change. Okay, here we are given sodium ion, which was gaseous, it became hydrated. So that means this is enthalpy of hydration of sodium ion. Here we are having chloride ion, which was a gas, it became hydrated, it became aqueous. So this is the enthalpy of hydration of chloride ions. And here we have sodium ion, which was gaseous, chloride ion, which was gaseous, combining to form an ionic compound, which is solid. So this is lattice energy. Because we said lattice energy is enthalpy change when 1 mole of an ionic compound is formed from its constituent ions in their gaseous state. So it is negative 781 kilojoules per mole. So we can tackle this question in 2 ways. The first way, we can use the Hess's law concept and we are going to use energy circle. So we can first of all reverse the lattice energy here. We can start with the ionic compound. That means we can start with sodium chloride, which was solid, and we are going to have sodium ion, which is gaseous, and we are going to have chloride ion, which is gaseous. So that's our procedure 1 in method 1, because we want to do this question in 2 ways. Okay, now we have again heat of solution here, because we can have that sodium chloride and we can add water so that we can get sodium ion, which is aqueous, and we can have chloride ions, which is aqueous. So here again we have sodium ion, which is gaseous. It can become hydrated by adding water so that it becomes sodium ion aqueous. Here the same, we have chloride ion, which is gaseous. It can become hydrated by adding water so that we get chloride ion, which is in solution form. So this is an energy circle diagram. So let's just try to relate. This is enthalpy of solution. This is lattice energy, enthalpy change 2. This is hydration energy of sodium ion. Then here we have hydration energy of chloride ions. So using Hess's law, we have 2 routes of forming sodium ion aqueous and chloride ion aqueous. One route is enthalpy change 1. So the other route will be having lattice energy, that's enthalpy change 2, then adding the hydration energies, that's enthalpy change 3 plus enthalpy change 4. Okay, using now the information given below, the information given up here, we can use, because we don't have enthalpy of solution, this will be equal to, we have our lattice energy, which is enthalpy change 2 as negative 781. But we have reversed this equation. We have flipped, in other words. So that means the sign will change to positive. So we're having positive 781 plus enthalpy change 3, that's hydration of sodium ions. So that's negative 390. Then plus enthalpy change 4 here is that enthalpy of hydration of chloride ions. Here we are given negative 384 kilojoules. So if we sum up all this using a calculator, we are going to get positive 7 kilojoules per mole. 7 kilojoules per mole. So it is a positive. That's the first way. We can calculate this question by using the energy circle diagram. So the other way is we can use our formula for enthalpy of solution. Remember we said enthalpy of solution can be gotten by enthalpy or lattice energy plus hydration energy plus enthalpy of hydration. That's the formula. But when you're using the formula, you have to know, or you have to assume that the lattice energy is positive. So in our case, we are given negative 781, but you have to say positive 781. When you're using this formula, you always change the sign of lattice energy to positive. Plus, the one for hydration energy, that means the hydration energy for this side will be the sum for the hydration energy of sodium ion plus the hydration energy for chloride ions. That means we are going to have negative 390 plus negative 384, which is for the hydration energy for that chloride ion. So this one, if you sum up, you are going to get positive 7 kilojoules per mole. You can use these two steps. But during the exam, if you are told using energy circle diagram, calculate the heat of solution of sodium chloride using the information given below. You have to use this method. But if the question is open like this, you can use either the methods. So let's go part B of the question, or the other information that we give. You are told draw an energy level diagram. Remember, we were having in our previous exam the two diagrams for energy level for both endothermic and exothermic reactions. So here we have gotten positive enthalpy change as our enthalpy of solution. So that means we are going to check the side for endothermic reaction. Your energy level diagram should look like this. So you have to have these two diagrams in your head or in your fingertip. So in our case, we are supposed to use this energy level diagram. So we are going to put our ionic compound to be sodium chloride because we are using sodium chloride. Here we are going to have sodium ion, chloride ion. Here we are going to have sodium ion aqueous. We are going to have chloride ion aqueous. Then here we are going to put positive 7 kilojoules per mole, and our lattice energy was positive 781, and our hydration energy was negative 774 kilojoules per mole. Okay, so we are going to draw that energy level diagram down here. So first of all, I have to have my axis. We have to draw our axis. So to label, we are having here energy in kilojoules. We are having energy in kilojoules per mole. And down here on the x-axis, we are having the reaction coordinate or reaction path, or we can say reaction pathway. So we are going to start down here. This side, we are going to have our ionic compound, and that's sodium chloride solid. Then we are going to draw our lattice energy. Okay, this is our lattice energy. Our lattice energy is positive 781 kilojoules per mole. Then up here, we are going to have our ions, that's sodium ion in gaseous form, plus chloride ion in gaseous form. So next, we can have our hydration energy. Hydration side will be here. Remember, we said when you get a positive enthalpy as your heat of solution, we are going to have our lattice energy to be greater than our hydration energy. So we are going to have hydration energy there. So in our case, the hydration energy will be the sum for that hydration of sodium ion plus the one for chloride ions, which are 384. If we add this, we are going to get negative 774 kilojoules per mole. Okay, we are going to have our ions here. We are going to have our ions as sodium ions aqueous, and we are going to have chloride ions aqueous. So down here, we can have our enthalpy of solution, and our enthalpy of solution, it's the one that we were calculating right now, and we have gotten positive 7 kilojoules per mole. So in doing so, you have drawn the energy level diagram for the change. So even using the energy level diagram, you can get the enthalpy of solution, this one. If you don't know the value of enthalpy of solution, and you have started by drawing the energy level diagram, what you can do is you just know how do you get enthalpy of solution. Enthalpy of solution is here using Hess's law. That means for you getting this products, that's sodium ion aqueous and chloride ion aqueous, what you can do is you can go through this root of lattice energy, which is positive 781. Then you add to this other root that comes up there, that's that of hydration energy, which is negative 774. So if you sum up this, what you are going to get still will be positive 7 kilojoules per mole, which we have written here. That's the end of our lesson.